that.
Hello. This semester, our Quant group project was, do these beverages need to aspartame it down? A look into aspartame concentrations.
I'm Mary Marszlewski.
I'm Cydney Pittenger.
And I'm Bonnie Jensen. My group and I will utilize this presentation in order to explain the purpose, background research, procedure preparations, methods, data analysis, and results for our lab project. The purpose of our project was to utilize the HPLC instrument in order to obtain concentrations of aspartame. The concentrations that we created for stock solutions equated to 0.04, 0.06, 0.08, and 0.10 milligrams of aspartame per milliliter. We also used the same HPLC instrument to analyze concentrations of 4 diet soda beverages, including Diet 7-Up, caffeine-free Diet Coke, as well as 2 unknown diet sodas from the caffeine lab. These are labeled as C2 and C3 accordingly. Lastly, we used the HPLC to analyze the City of Ripon wastewater.
We wanted to share a little background on aspartame before going into our project. Aspartame is a dipeptide that is used as an artificial sweetener or sugar substitute in a lot of food products. Some of these food products include processed foods such as cereal and many beverages, including a lot of sodas and diet sodas. The chemical structure of aspartame is depicted on the left. Aspartame has been approved by the FDA to be used in these foods and to be consumed by the general public. There are suggestions for those who have pre-existing conditions such as phenylketonuria, PKU, which is a birth defect that does not allow the person to process the amino acid phenylalanine, which is present in aspartame. Despite being approved by the FDA, aspartame has been the center of some controversy. Multiple studies have been dedicated to looking into the negative health effects aspartame may have on the body. These effects may include the development of cancer, ties to Alzheimer's, obesity, and more. The suggested limit for aspartame by EPA is 50 milligrams per kilo a day. This means that a 60-kilo person can consume around 3,000 milligrams of aspartame a day before exceeding this limit. Before starting our lab project, we wanted some background information on how to analyze aspartame using the HPLC instrument. We looked at a study performed by Ziegler et al., where we saw their analysis of aspartame using mass spectra and a chromatogram. Looking at the diagram at the left, that's their mass spectra graph of the aspartame. And what we saw was around 300, there was a peak at up to 293, which is the aspartame. So we knew going into our analysis of aspartame using the HPLC instrument, that is the peak we wanted to look for, which would be around 294 because of the HPLC instrument being N+1. So we knew that's where we needed to look for the mass spectra peak. Looking at the diagram on the right is the chromatogram peak, which around 12 minutes is the aspartame peak. Again, showing us that when we run the chromatography and look at it using the chromatogram, we need to look for a peak for aspartame around 12 minutes.
Our procedure preparations consisted of beginning with aspartame and creating our stock solutions. In order to get the specific numerical values, diluted the aspartame with formic acid as well as deionized water. The principal use of formic acid is as a preservative and antibacterial agent. The diluted use of formic in labs pertains to the extraction of macro and micro elements in order to be evaluated and analyzed. The 4 different diet soda beverages were diluted with deionized water before transferring to vials. The City of Ripon wastewater prepared by first filtering through a cotton, then the cotton was washed with acetonitrile, and finally it was transferred into a vial ready to be analyzed. The method of our lab consisted of using a high-performance liquid chromatography, or previously mentioned as a HPLC instrument. The HPLC works with the high-pressure pump that is used to generate a flow rate. This allows using a much smaller particles for the column packing material to have a greater surface area for interactions between the stationary phase and molecules flowing past it. This results in a separation of components in the mix, and due to their different degrees of interaction of the absorbent particles, causes different elution rates for the different compounds and leads to a separation out of the column. The separation is then detected by the instrument of dyes, resulting in peaks being shown on the screen in order to be interpreted. We ran at each concentration through the instrument and data. We then analyzed our data and noticed that our stock solutions looked until we got to the 0.10 milligram aspartame per milliliter solution. This was a repetitive error because we ran the solution multiple times, even numerous stock solutions. The R-squared value looked very good for the data of the 0.04, 0.06, and 0.08 solutions, however, lowered with the addition of the 0.10 stock solution. We use the same method and the same high-performance liquid chromatography instrument for the said diet beverages and wastewater.
On this slide, we can see the peaks that we obtained from each of our solutions. So starting from the left, that is the peak that we found for the C2 solution for aspartame, the peak of, moving over to the right, the peak of aspartame for C3, then the peak for caffeine-free Diet Coke, Diet 7-Up, and then finally the stock dilutions. As we can see from these peaks, for the most part, they are somewhat similar to each other, and we did find all of these peaks around 12 minutes, which is what we expected to find. This next slide shows the peaks comparing the stock dilutions on the right to the wastewater aspartame peaks on the left that we found. And this is not what we expected from the wastewater. It obviously looks different than the other peaks that we found, but we did still find this different peak around 12 minutes as expected for aspartame. After obtaining all of our data and our peaks, we created a calibration curve. We used the concentrations of our stock solutions, which were 0.04, 0.06, 0.08, and 0.1 milligrams per milliliter of aspartame. And when we ran the HPLC instrument and obtained our peaks, we then used the processing software on the HPLC instrument to take the integration of each of these peaks at each of these dilutions. And after finding the area under the aspartame peak curves, we graphed this versus the concentrations of the stock solutions to obtain this calibration curve. This calibration curve, we got an R-squared of 0.966, which it could be better and is most likely not as close to one as we would have liked it due to the repetitive errors we saw in the 0.1 milligram per milliliter aspartame dilution, but it's still above 0.95, so it was good enough and relevant enough for us to move forward with analyzing this data.
So in analyzing our results, we took the diluted concentration of each unknown that we got, or each solution that we got, in the milligrams per milliliter, and we did a series of calculations that is shown on the bottom. And in that series of calculations, we found that wastewater had the lowest concentration of aspartame, which wasn't very surprising because it's not a soda. And the diet decaf Coca-Cola had the highest concentration of aspartame, possibly to make up for the lack of caffeine. And none of these solutions or drinks are even close to the EPA limit for aspartame per day that a 60 kilo person can have. So it's very safe to drink unless you're taking like an entire 12 pack, but I don't think many people do that. And for our t-test, we wanted to find significance between all of the drinks. So we used a case 2 t-test. When we tested the diet non-caffeinated soda versus the diet caffeinated soda, we found a t-calculated value of 0.724, which compared to the t-crit value of 4.303 meant that it was insignificant. For the diet non-caffeinated soda versus the wastewater, we found a t-calculation value of 0.819, which again was insignificant compared to our t-crit value of 12.706. And in our diet caffeinated soda versus the wastewater, we had a T-calc of 0.420 and actually 0.426, and the T-crit value was 4.303. So again, it was insignificant. What does this mean? It means that the diet non-caffeinated versus the diet caffeinated soda did not have a significant difference in aspartame concentrations. Neither did the diet non-caffeinated versus the wastewater, although this did have the most difference in all of the things that we calculated, even though it was still insignificant. And the diet caffeinated soda versus the wastewater was also insignificant. So things to consider in our project and what we did is that the HPLC instrument was run at 254 nanometers instead of 280 nanometers. And 280 nanometers would have been better for identifying aspartame, but 254 was still acceptable. We still found our peaks at about 12.8 minutes in our stock solutions, and we used that as a reference for the other solutions that we tested, and we did find those peaks nicely in our chromatogram. And we could have looked at the mass spectra too, but we ran MS/MS when getting our values, and it should have been MS only if we were going to look at those peaks. So all we looked at was the chromatogram. So in the future, if someone redoes this lab, it should be done using 280 nanometers with the HPLC and the MS instead of the MS/MS. And that's it. Thank you for listening.